This is a video that deals with finding a little bit different quantity about the normal distribution. The previous two examples dealt with finding probabilities about the normal distribution. This one deals with finding a particular value of a normal random variable that satisfies some condition. And in this context, or in this problem here, we want to find the value of the standard normal random variable such that 0.01 of the area lies to the left of this value. So the picture here, again, I recommend drawing out these pictures. So this is a particular value of z, and I'm going to call it, so here's big Z for the random variable. This is a particular value z, and to distinguish it, I want to call it z naught on my picture. Now I got to think about, okay, this is, where do I put this z naught? Do I put it way over here in the right tail? Do I put it more towards the middle or more towards the left tail of the distribution? If I look close here, it says find the value such that 0.01 of the area lies to the left of z. Well, I know maybe from a little experience that if I'm at 0, the area to the left of z is 0.5, and as I move to the right, the area to the left of any z would be bigger than 0.5. So I know, because this area is so small, 0.01, that I've got to be in the left tail of the distribution. So here, let's say some z naught, and I want to find this z naught. What is this thing? Given that this area here is 0.01. Okay, another way to think about this question is to find z naught such that the probability, the standard normal variable, is less than z naught equals 0.01. Okay, well, so this is a little different than what we've seen. Again, we're finding a particular value of z given a probability. For the previous examples, we were given a value of z on the axis and asked to find a probability or asked to find an area. The tables that I have will not give me this directly. I have to do a little manipulating. If I look at table C here, again, the area is from negative infinity to some z-score. Well, but it's just the z-scores to the right of 0, from 0 to 3.39. If you're looking at your table, I'm gonna make this a little bit brighter here. Oh. Okay. So I've got to somehow use the right-hand side of the distribution to come up with this z naught. And what I'm going to do is draw a second picture here. And I'll tell you that, well, actually, you know what? I don't need to draw this picture yet. In fact, I don't think I need to draw it at all. So we'll just ignore that. Alright. This z naught here, because it's to the left of 0, z naught is inherently negative. But also, one thing I do know about this distribution is that it's symmetric about 0. So the distance from here to here is z naught, and the distance from here to another value would also be the distance, the distance from here to here would be the same as the distance from here to here. I shouldn't call this distance z naught. The distance from here to here would actually be negative z naught, and that's because z naught is by itself negative, so negative z naught would be positive. And it's symmetric in the sense that, well, the area to the right of this point is 0.01, just like the area to the left of this point is 0.01. So if I redraw my picture here, I'm just going to focus on the right tail of what I've got. Here I've got negative z naught. The area to the right here is 0.01. That means the area to the left of negative z naught is 0.99. Okay, so what I want to do is I can use table C now, because table C for given z-scores gives me areas to the left of that particular z-score. And what I've got is a z-score that has an area to the left of 0.99. So I'm going to look on table C here, and I want to look to find an area in here that is closest to 0.99. The one that is closest here, let's see, so I got 0.9891, 0.9901. This seems to be the closest area I can get to 0.99. The z-score that corresponds to this area is 2.33. So we see that there. So at 2.33, that is my value for negative z naught. So what does that mean that z naught is? So therefore, the z naught that I wanted to find to begin with is negative 2.33. And that is the value of z that has this condition on it. Notice, again, this is positive. It makes sense because it's to the right of 0 on the picture. And this value is just the negative quantity of this, but in the left tail of the picture here.